Where's the? Oh, sorry. Should I get started?
Yeah. We're supposed to put our names on this.
Yes.
Even though we put our name on the top line. So.
Good morning. Welcome to DETNET. We're going to get started. I'm Lou Berger. This is Pat Taylor. Our secretary, Yoni, is remote. Our agenda and slides are in the normal place. Please feel free to go download them and watch them as we go through. We start all of our sessions with the note well. We're late in the week. You should be familiar with it at this point. Basically, anything you say here will be part of our permanent record and subject to our IPR rules. As usual, we are streaming audio and video. If someone wouldn't mind jumping on Jabber, that would be great. If no one does, I'll jump on in a moment. We usually do our joint minute taking, sort of crowdsourced minute taking. The link is off, you can see here, or it's easier to get off the tools page. You go to tools, working group, minutes. You'll also find a link to the Etherpad there. My bet is if you Google, you'll find it also. Please jump on and contribute. Our agenda has not been changed from what has been published. We're going to go through a number of our working group documents and then talk about some work that we're looking to adopt, and then some other consideration pieces. The last two documents or presentation slots are really more informative than work that we're going to be necessarily taking on, at least immediately. The norms document talks a lot about what's going on in TSN and how TSN mechanisms, queuing might be applied to DETNET. Whether that ends up coming in as a working group document or not, it's very useful work either way. The last piece is we're going to hear on network calculus, which could help inform how we model some of the parameters, both in what's happening inside the network, so things that would support path computation, as well as parameters that could be used for describing our services. So this is really going towards helping to inform the piece of work that we haven't really gotten to, and I'll talk about that in a second. Oh, and as of course always, please discuss things on the mail list. The IPR process, I think everyone's familiar with. We don't have to spend too much time on that. Where are we with our documents with respect to deliverables and milestones? We have 3 documents that are pretty mature. We want to last call them. The interesting thing is by keeping these alive, we actually keep finding little pieces that we think we understand, and we probably do, but as new people come in and read the documents, we find they don't understand what we meant it to say, and in fact, the documents really don't say what we think. So by keeping them alive, it's actually been good because we can go and fine-tune these documents. So there really is a trade-off of publishing, because it's nice to have RFCs and the work is done and we can move on. There's a trade-off between that and making sure we've documented things, not only so everyone in this room understands it, but more importantly, so the people that come along next understand it. So we should be thinking about that as we go through the last call. On the agenda, we have a couple of our documents. The data plane solution one is going to be a really good and important discussion. We had a lively debate on this document at the last meeting before adoption, and we have a lot of open issues, and we have a good block of time of our agenda allocated to going through some of those issues, and hopefully we can make some good progress here, which of course we'll confirm on the working group list. So I was mentioning that the last presentation is helpful in informing some of our thinking. Part of the reason why we as chairs wanted to have that slot when it was offered is that we don't have any proposals right now for our Yang models. And that's the last piece of deliverable that we have is we need something to describe what is happening on inside a DETNet node, and then also how to provision those a DETNet service. So one of our motivations for having a talk that is not on a draft, but is providing background, is to help getting the working group thinking so we can get some contributions in this area. I remind folks we're contribution driven. If you want to participate in the working group, you want a new space to add value, here's a good place to do it. I guess that's my last slide. So with that, we'll jump into use cases.
I'm Ethan Grossman from Dolby Laboratories, and this is the update for the DETNet use cases draft. We'll go over the goals, plans, status, the common themes, which is something that I wanted to just review briefly because it informs a lot of other things in the DETNet. And we have 3 new use cases, which we'll cover very briefly. So the overall view of why do we have a use cases document? What is it? It provides the industry context for DETNet goals. What are the use cases? How are they addressed today? What do we want to do differently in the future? And what are we asking the DETNet working group and the IETF to provide in order to enable these things? The use cases are organized by industry, but in addition, we've broken down the different use cases into a sort of set of common factors, which we refer to as the DETNet common themes. So these are the commonalities between use cases, and as I said, I'll review those very briefly. The use case draft functions as a yardstick for the functionality of any proposed designs. For example, it provides a way to look at, what is the requirement, and then is our solution, for example, architecture and so on. What is it proposing, and will it satisfy the use cases? The use case draft explicitly does not state specific requirements for DETNet, nor does it specify design, architecture, or protocols. We made, as a working group, a conscious decision not to have a requirements document for DETNet. We're going from use cases to architecture and design. And one quality of that, alluding to what Lou was saying a second ago, was that there are ways in which, as the design evolves, it may need to inform the use cases and say, well, we've got a solution that really looks about right, but it doesn't quite satisfy this one particular thing. So maybe we'd have to go back and actually amend the use cases to say, well, no, that's not quite it. So there has been that, but so far there haven't, in the recent year since the last update, there hasn't been any such correction required. So that's been stable. So the plans for the use case draft, as Lou was saying, we feel the draft is pretty mature, and we're looking at last call, but again, there is that quality that if something changes in the architecture, that we would want to possibly modify the use case draft, but so far, again, that hasn't been necessary. So we have 3 new use cases which were introduced in the last few months. These are the private blockchain, the mining, as in mining for ore, not as in data mining, and network slicing. And again, it's not a complete solution for network slicing, but it provides some useful technologies for developing network slicing infrastructure. So I just wanted to look over the common themes. I'm not going to literally read over all these to you. These are all pretty much the bread and butter of DETNet at this point, what we're trying to do, and what the basic premise is. But they're interesting to keep in mind that this list exists and that these are discussed in the use case draft. This is page 1 of 2. There is another page. But the idea is that this list also serves to inform the security draft, because one of the things that we've done in the security draft is to look at each of these particular sort of properties that this kind of network would have, and what sorts of security issues are there organized against these individual properties, in addition to what are the security issues that might be associated with a given use case by industry. So this is a good overview of just a different way to organize the way the goals of DETNet. So the mining use case, again, I'm going to go only very briefly through these use cases. I'm not really doing them justice, but just to have a brief overview of what they are. So for the mining use case, if you imagine a sort of a large open, like a pit mine, where you've got a huge area filled with large machines digging ground and moving earth around and putting up big piles of stuff. It's a very dangerous place, and the trend in recent years has been to automate all of this so that the people are actually remote and they operate all this equipment, via video links that, show what's going on from the view of a piece of machinery, and then they operate the machinery with levers from a distance. So there's a lot of real-time wired and wireless communications going on between these machines. And in addition to all that going on, there's a lot of sensors distributed throughout the area to determine, for example, if a given pile of something or other is likely to be moving or becoming unstable. You want to know that. So a lot of these sensors are using this LP1 type stuff to move those. There's also voice communications among various people along the different stations that are monitoring all this. So the idea would be, it would be nice to put all this into DETNet, and particularly if you have wireless parts of DETNet, that would be awesome. So it's an important use case. Blockchain, if you don't know what blockchain is, I'm not going to be able to explain it to you in 30 seconds, but if you do know what it is, you probably know more about it than I do. But the point is that it's a process that can be done on a corporate network, not just the Bitcoin type blockchain that's on the open internet. It's specific applications, of which there are actually quite a number, that in which you can facilitate the process of what they call consensus, where the computer systems have to talk to each other and move information very rapidly and reliably between them. It's usually not a ton of information, but the latency is important, and the negligible packet loss is important. So all of these things contribute to be useful in blockchain. So for network slicing, again, DETNet it's not exactly a pure application of it, but if you look from the bottom of the pyramid of requirements going up, you find that the requirements in developing a network slicing infrastructure include being able to have guaranteed bandwidth, low latency, low packet loss. All these would be very useful when implementing these kinds of isolated network slices, because it enables functional performance and security isolation between the slices. And in the end, it's very desirable that the behavior of one slice not affect the behavior of any other slice. Question from Greg.
Oh, thank you. Greg Mirsky, ZT. I agree that, yes, network slicing has one use case, or, one area of use cases that referred as ultra low latency and jitter, because, for example, new mobile backhaul doesn't really have strict latency packet loss requirements. It's just bigger pipe. And for example, massive IoT might not have very strict requirements. Industrial IoT, which falls into the first low latency jitter scenario, yes. So basically, out of 3 scenarios that identified by 3GPP, one definitely fits DETNet. I agree with that. But we might be more specific when we talk about net slices to refer to this scenario, rather than say that all net slices require guaranteed.
Yes, that makes good sense.
Greg, if you have any suggestions that could help clarify that in the document, that would be great. Propose some changes on the list, and we can get it into the document.
I'll be glad.
Thank you.
Thank you.
Thomas Eckert. So to me, it's very simple, right? If somebody wants to have DETNet services, and a service provider needs to provide them in a virtualized environment, then slicing is the new buzzword, how to define virtualized environments that can provide, let's say, hop by hop guarantees, right? But to me, it's not quite clear if it's a new use case by itself, right? It's just a virtualization of a DetNet service. If all the services people want to have from slices are not DetNet services, but any other services, like even, low latency, whatever, guarantees that somebody wouldn't call DetNet today, then, they could also, in my opinion, be provided, through a slicing architecture that doesn't rely on DetNet underneath. So I think that is my claim. I'm not 100% sure, right? So the question is, if all the services required by slicing are non-DetNet services, if you would implement them natively, would you still be able to make a case that in the slicing environment you need underneath more DetNet? That would be making it a real use case. Otherwise, it's just a virtualization, way of whatever DetNet service you have in before.
Well, that's a good point. And I think one way that it was phrased was that DetNet is a candidate technology for use in the infrastructure of network slicing. And so I think in that case, yes, it's not a pure use case. If people feel that it's not appropriate to have that in here, please let us know on the list, and we can discuss it further. So I have one more slide that briefly discusses network slicing, but I'm not really going to go into it. But the point is, it provides the technology for providing isolation between slices, in that sense, functional performance security again, and perhaps the ways that DetNet enables you to specify a number of redundant paths and so on could help with reliability and so on. So that's a matter of implementation, I guess. Anyway, that's what I have.
So Stuart, Brian, I was just going to reinforce the point that I do think that there's an extremely good match between what I've heard of the network slicing 5G requirements and the work of DetNet, and we should be seriously investigating its use. It would be a mistake to take this use case out of the document.
Whoever speaks at the mic, please really lean into the mic. If you don't lean in, we can't hear you.
Okay, sorry.
You have to get very close to the microphone. We couldn't really hear you, I think was the point, Stuart. If you could please repeat.
So the point I was making was that you were asking about whether this should be in the document. Having looked at the problem for quite some time, I think absolutely it needs to be in the document. It's a perfect match for something that we know that 5G is asking for, and it would be a real mistake if we took this out.
Thank you, Stuart.
Okay, so my name is Tal Mizrahi. I'm from Marvell. This draft is about security considerations in DetNet. It's a collaboration between a group of people led by Ethan Grossman, and the group also includes Andrew, Sabir, John, Henrik, Kevin, and Norm. This is the outline of the draft. We've presented this a couple of times in the past IETF meetings, and these are the main sections in the draft, or the main themes in the draft. Security threats, basically what are the possible attacks on deterministic networks. Impacts of these security attacks, which means what happens if there's a successful attack. Mitigations, which means what we can do to try to mitigate or to prevent some of these attacks. And finally, there's a section which associates each of the attacks with use case themes. So the use case themes are basically based on the use case document we saw on the previous presentation. So this draft has been around for a few months. We presented it in IETF 98, in IETF 99. There was quite a bit of feedback. It was recently adopted by the working group. So right now we're at draft 01 of the working group document. The main differences between the previous version and the current version. So there are two main differences. First of all, in the impact section, significant changes were made in this section. First of all, a lot of clarifications. And also, we revised the impact to use case mapping. We'll talk about that in a minute. Another section that was significantly revised is the section which associates attacks to use cases. We'll also talk about that in a minute. Okay, so like we said, impact means what happens if there's a successful security attack. So basically, one of the things we see in the impact section is a mapping between impacts and use case industries. So in each column of this table, you'll see a different use case industry. And then each row kind of shows a different type of impact. So for example, if we look at the first row, we see the criticality. So we can see for each industry, whether the criticality of a successful security attack on DETNET, whether it's medium, high, or low. And on the second row, we see the financial impact and so on. So this kind of shows you a mapping of what are the impacts of each type of industry. So this is something that was significantly revised in the current version. Another aspect is the section that maps the attacks to use cases. So we kind of have a subsection about each use case theme. And what we had in the previous version was that for each use case theme, we had kind of an outline of what are the topics that we plan to discuss. It was phrased in the form of a set of questions. So in the current version, this text was significantly revised. We have more detailed text which maps for each of the use case themes. It describes what are the main security aspects which are related specifically to that theme. So at this point, looking forward, the next steps we are thinking about, we would like to discuss with the working group. First of all, so far, the format we've been working on is kind of a design team. It's not formally a design team, but it's a group of people who met periodically and worked on the document. And now that it's a working group document, we're kind of reconsidering this format. We're encouraging people who are interested in this work to join us to contribute. So that's one aspect. Another thing is that we would like to encourage a lot of reviews. Okay, we'd like people to read the document, to try to see what's missing, to try to see what's wrong. So as many reviews at this point, it would be best. It would improve the document. And this is a good time for anyone who hasn't read the document yet. This is a good time to read it. And also another aspect that we need to look into in the near future is what the data plane design team has been working on. We need to look at it from a security perspective to try to see the possible threats and the possible security aspects that need to be addressed in this document. Okay, so this would be a good time for questions and comments.
Thank you. Greg Mirsky, ZTE. I just want to ask you what you think of level of threat or importance on attack on OEM, because OEM will be used for SLA assurance in a DETNET. And if somebody skews your measurement, that will trigger false negative. Okay, so do you think that it, because again, I understand this is a generic problem. It's not a problem specific to DETNET, but is it reasonable at least to mention that OEM can be vector of attack to destabilize DETNET environment?
Okay, it's a good point. Do you think that there is something here which is different in DETNET than conventional networks? I mean,
I think, well, again, that depends on how important the performance measurement is for the environment, because SLA and SLA assurance for DETNET is important. Then it might be really used to destabilize, because in some networks they do performance measurement only for the billing, right? Here, the performance measurement, I can envision that will be determined that you have to reroute, which, you know, disturbing to the network. Any change in a topology that you have to force and switching paths may result in packet loss because it's not instantaneous. So you might have some packet loss result of false unnecessary switchover.
Okay, it's a good point. Good point to consider. This is the kind of feedback we're looking for. You're missing this stuff in the document. That's good feedback.
It's
Thanks.
not just packet loss you're going to get as a result of an inadvertent switchover. You're going to get delay jitter changes as well.
Yeah.
And in fact, actually, I don't remember seeing it there, but we may want to look at some of the convergence control technologies in the underlay in order to preserve those characteristics in the network.
Absolutely agree. Yes. Protection methods and restoration, that's, again, I agree, that's subject of itself because there could be absolutely legitimate service degradation or metrics degradations and even failures detected in the network. But that might be induced as a result of attack on OEM skewing the measurement. Because you can easily imagine that not just injecting packets, but just intercepting packets, holding them for longer, and thus producing wrong measurement results.
Okay, thank you.
It would be good just to address your 3 points here from the chair perspective. In terms of formats, there's nothing wrong with holding meetings of people who are working on the document, authors. Now that we've switched to a design team, away from the design team format into the working group document, it would be good if you publish when you're going to have those meetings and open them up to the working group. If you don't, just remember that any decision taken by a set of authors is not a decision by the working group, and you need to, if you come to some agreement on a position, you should bring that to the working group, present the proposed changes, and see if there's any feedback on the list. So that's really important. But there's nothing wrong with having authors meetings. So don't feel like you should stop that, particularly if it helps progress the document. In terms of your comment on soliciting a wider input, I think that's just right. One of the things I'd like to ask the working group as well as the authors to, when they're reading the document for the first time or reading it again, is to look very carefully of what is being discussed, if it's in scope or out of scope of what we're doing here. For example, we're not doing control plane yet. That's out of scope where we are right now, but we might do it in the future. So maybe that's something that belongs in an appendix, but not the core of the document. So we don't want to lose good material, but we want to make sure that the core of the document is focused on the work we're doing right now.
Okay, thank you.
So now we're going to go remote to Yoni.
Yoni, please queue up.
Yeah. Yeah. Can you hear me?
We
Yeah.
hear you, but we don't see you.
Okay.
You want to see me? Okay.
Maybe not. Of course we want to see you. Yoni.
All right.
Oh, there you go.
All right. Good
hope-
morning. Good very early morning. Okay. All right. So you have the slides up. Okay, good.
And we're ready to go. Next, when you want us to go to the next slide.
Okay. Okay. So hello everybody. Remote again. So Jouni Korhonen working nowadays for the Nordic Semiconductor. And so this is about the data plane, the recently adopted solution document, and the next slide, please.
There's a delay in you seeing us switch the
Yeah,
slide. Just
okay. So we got a very thorough review from Stuart, so thank you. So I recorded down some 40 plus comments in the document. So those who have been reading the solution document can find those comments embedded in the current 0.0 version of the draft. And then there's been a somewhat vivid discussion on the email list. This presentation is mainly concentrating on the data plane. So the transport part and some of the things that the services that we need to provide for the service layer. So next slide. I just want to remind you about the DETNET services, and these are extracted from the architecture draft. So we have the zero congestion loss, bounded latency and zero, and the high delivery ratio. And the next slide, please.
One comment I'd like to make here is, and this was made privately to me, is that the objective of DETNET is the delivery ratio. How we achieve it is mechanisms that we decide to define in the working group, and it's okay for us to have multiple definitions. The particular question was related to whether or not network coding was in scope or out of scope, and the answer is that is in scope. We don't expect to be working on it for a while, but if there's a proposal for it after other things have stabilized, that could come in to satisfy that last service. All right, I'm on the next slide now.
Okay, thank you.
Sorry, we have someone at the mic.
Pascal Tubert, network coding is mentioned in the architecture. It doesn't mean that we have to implement it. What we have in the architecture is very interesting for positioning functions, whether we implement them or not. But I think it's good, and we need to keep the network coding positioned inside the architecture. So if people think about it, they need to know where it is and what it does.
Yeah, exactly. Thank you, Yannick.
Okay, so again, borrowing stuff from the architecture document. So reminding you about the layering what we have. So and where we are now with this document is the transport layer and a bit peeking into the service layer, because we have a couple of functions in the service layer that, for example, Norm is going to talk about, especially when it comes to packet sequencing and application and elimination. And the this talk is somewhere in between. So in the solution document, we currently describe two solutions. So we have the IPv6 encapsulation, and then we have the transport solution that is based on the existing pseudowires. And if you read the document and how it starts, the IPv6 encapsulation is mostly intended for the native IPv6 end-to-end DETNET service cases where the end system are DETNET aware and input and output DETNET service flows natively using the IPv6 traffic. And then we have the pseudowire encapsulation, that the one of the use cases that we address here is the emulated DSN service, so the island interconnect. But it doesn't exclude that you could actually talk, the end systems could natively talk pseudowire-based encapsulations. Okay. Then the next slide. So what this presentation is mostly about, and the decision discussion points, they circulate around two topics. So the so as I said, we have the IPv6 and we have then the pseudowire, MPLS pseudowire-based solutions in the document, and the how the service layers is expressed in those encapsulations, and we need to discuss and decide whether we aim them to be unified or whether we let them to kind of go different ways. And then the other kind of big question is about the what kind of solution we want to have our PSN that currently is modeled after the pseudowires. All right, next slide. So about the unified service layer. So for the current solution document, so they are not really aligned anymore how they look on wire. So if you then think about how you would actually make chips and the pipeline logic, you need to have 2 different paths if you want to support both transport types. So the first question that I have for the working group, kind of going forward on how to model the document in the future, is like, should the data plane solution aim for a unified on-wire format for the service layer? So for IPv6, and then the something else that is going to be something MPLS based. So should we look at how we package them in the same way, or let them diverge and have their own encapsulations, for example, for sequence numbering and how they identify the flows, as long as the functions are the same? So this is the first question that I look for an answer.
Stuart,
please.
I think part of the answer lies in, are the only 2?
By the way, it's Stuart.
I did say Stuart, didn't I?
I didn't hear you. I'm sorry.
Sorry. Part of the answer lies in whether these are the only 2 that we need to support. So if it turns out that there's some industrial format that we also need to support, or plain old-fashioned v4 needs to be supported, that tends to push you in one direction. If these are the only 2 that you need to support, then doing an optimized one for each one possibly makes sense. But it depends how many others that we might need.
Okay, that's a fair point. So we had, for example, regarding the IPv4 part, we had a kind of agreement that we are not going to look into IPv4 solution. If someone goes for an IPv4, that's their problem. Well,
let's be careful. I think we said that if someone did v4 over TSN, and that we would support interconnected TSN domain.
Yeah. Well, we need to make sure that kind of interconnect solution works, but describing a solution, especially for IPv4 as for example, transport solution, I don't think that we should be doing that.
So Stuart again, well, I take the view that if customers need v4, and in a lot of legacy worlds they might, I suppose, we should support it. I don't think we should use this as an excuse not to service customer need. I don't know whether they do, but we really need to be clear on whether it's needed.
Yeah. The question is, to me, is whether we support it as an end-to-end DETNet service or as yet another TSN service that's being carried over DETNet. And I think we've taken the latter position. I'm not saying it's the right position, but I think that that's the direction we've been headed down. If we want to do something different, that's a good thing to raise.
Well, what do the use cases tell us?
The use cases don't go to that level of detail. They're high-level applications that says we need to support industrial mining, as we heard earlier. Whether the miners don't care whether they're v4 or v6, they just don't want a piece of machinery to run into them. So one of the points that was made, I can't remember if this was on list or privately, is the whole discussion about whether we should be continuing to use talking about pseudowires, or should we just be talking about what is it that the data plane looks like and not being worried about being tied to the all the pseudowire references. And I think it would be good to hear from the group on that. And I'm not sure if you're going to get to that, Joni, later, or if this is what you were thinking of also covering in this point.
Yeah, so I have some points later on about, so
then let's defer to the conversation till then.
Yeah, so my as I said, I tried to kind of go into that direction. So I rather interested in the on-wire format and what is the kind of semantics on certain thing that I can extract from the flow. So given some technologies, I don't think that we should actually care that much how packet got into some point, as whether it came over the MPLS or whether it came over IP or something. So if we can unify the step further that are DetNet specific for certain processing on the service layer, that would be great, because then you can actually reuse some of the logic that you have in your fast path processing. And that's basically also the thing that what led to this question. So whether we want to stick with the kind of unified format, how you encode stuff into the packet, or whether we let them go, as Stuart said, optimized for a certain specific transport. And I just, because this is a one big question in the whole document, how you are going to split and how you're going to do that in the future. So like,
Yone, do you view that what we have now is unified or separate?
it's a separate. So we started to go on the path that we defined for IPv6. We started using the extension headers, and we use some of the IPv6 fields for certain service layer functions. So that's a clear indication in the solution draft currently that it's going to separate ways. And
So I think
I
with
just
respect
want to
to
confirm whether we continue on that one.
Yone, 1 second.
Okay.
So I think with respect to this specific question of whether or not you're asking, I want to make sure we're all clear. You're asking for feedback on whether we should stick with the current approach or try to go back to the original idea of having a single unified on-wire format. We haven't had a lot of comments in the room, but no one is objecting to the current definition of using different formats on the wire as long as it matches the DetNet service. So I'll just correct me if I'm wrong, Yoni. Did I paraphrase correctly?
Yep, that's correct.
Does anyone want to come to the mic and object to the path that the document currently has, where we're currently headed, where it is okay to have different on-wire formats, and right now for V6 and for MPLS environments, and maybe in the future it'll be another one, but we're not there yet. Norm is coming to the mic. Hopefully not to object.
Norm Finn, I think it's great to have both formats. I think there's a legitimate question whether it should be split into two drafts, but for sure,
We're not
both
there
formats.
yet. Let's just
Sure,
stick with the
both formats.
technical. So I think, I thought someone might be else coming in. We should consider this point closed, at least in the room. I think that when we send out summary notes, the next version of this document should remove this question, and we can consider it closed.
Okay.
Good. With the current document, which allows different formats. The question was, what's the answer?
Okay, Greg Mirsky, ZT. I think it make our work much more easier and documents more readable if we extract DetNet layer definition in one document, and then we might have DetNet over different technologies as separate documents. It's very similar to what's done in other groups, like, let's take, I don't know, segment routing. There is segment routing MPLS, and there is segment routing IPv6.
So to the question 2, you're saying let's go a separate document.
Yes.
Okay. Does anyone object to separating out that piece? We see no objections in the room. As always, changes need to be confirmed on the list.
Okay. So basically, we go with the route that we already chose, and let the different transport types have their own encodings.
Right, and also to to sort of start breaking this document apart.
Yep, that's actually next question so the question number 2 is not really valid for this one. So if you go to the next slide. So this is actually the bigger question now. So like currently we have IPv6 and the MPLS based in the same document. So following what Greg said, so this is now the question number 3. So should we split that into 2 drafts? So what we have currently, so basically saying that every time we have a different type of transport data plane solution, we just spin out a new document that describes the details, how you encode that information and the dirty details.
So what I heard was that yes, we should split it out into separate documents, and I didn't hear any objections to splitting it out into separate documents. I think I heard the suggestion that it should actually be 3 documents, kind of with an overview document and one for each encapsulation. I don't know. I'm not sure whether we need that because we already have the architectural and other things. So I'm not sure.
I'm myself in favor of 2 documents because we have all the architecture documents and so on that we know actually what we are aiming for. We just need to kind of, the discussion on the, for example, the elimination, so the pref part that Norm is going to have later on, that might change.
Johnny?
Yep.
I have one further comment here. I'm also in favor of...
Name, please.
Lou Anderson. I'm also in favor of splitting, but I would actually like to keep the document one more version where we actually sort out all the issues before we're doing the split.
Yep.
That seems reasonable. I think the author should be allowed a little flexibility as to when they do the exact split. This is not, we're not like about to last call it. So it's, if you think it makes sense to do 1, 2, or 3 versions and then do the split, that's great.
Yep.
But I would ask to start noting, at least put in a comment that this document's going to be split and noting where things are going to end up.
Okay.
Pascal, you mentioned in question 2 a split between the lower layer functionality and the upper layer functionality, like servers, common service, etc. And I think that's back to the discussion of having layers and what belongs, which layer this particular document is addressing. And as long as you talk about frame encapsulation and formats, I agree. These are those 2 documents we want to do, and I'm completely with that. Jumping ahead of what Norm is going to talk about and what I'm going to talk about, there are upper layer services that I don't think they belong to either of those documents, but there is other work which is taking place. Some of it belongs to the traditional layer 2, layer 3, which we are doing here, and some of it belongs to upper layers, and it's going to happen probably somewhere else. We don't have to put all this in your document.
Yeah. Okay.
You have Pascal has a document on transport services, sort of thing that rides above DETNet. So yeah, absolutely. We're not going to make one document that covers all layers of the network.
Right, and beware, in this room, when we say transport services, we think like ITU. We think down there in the forwarding plane. In the rest of the IETF and some other area, when we pronounce transport, you think about something very, very, very different. So that's part of my priming document.
Right. The routing area tends to talk about transport as network transport services, not transport protocols, which is the transport area and application area.
Right. So my document is about the other thing, right? Not transport services, as you just said, right, which people hear.
So you're in the minority in this room, but you're in the majority in another room. So that's okay.
Okay. All right. Can we go forward? I still have 3 slides. So the next one. Okay. So then about the thing that we had in the current solution document that was modeled after the pseudo wires. So so along the discussion while we were writing the solution document, we kind of found out the 3 ways to describe what the pseudo wire based solution could be. And just saying that the drivers behind why we actually went for pseudo-wire-based solution in the first place, they were quite kind of practical. So we found a transport technology that has a control word and sequence number and existing standards for that. And we have a clear description how the sequencing works. It even describes the reordering and the duplicate elimination already. Not that it has been successful, that has been pointed out multiple times that it's not really deployed, but it's still great to find a reference in a documentation that someone has been thinking this before. And then we had the, from the DETNET, we had the relay concept, and we kind of found a close fit that from the multi-segment pseudo wires, and we modeled that after that. And we could find a lot of similarities. So that was the reason why we went for the pseudo wire-based solution in the first place. We were not like in the kind of in love with the technology otherwise. So the current ways of describing the solution, they could be the way that is currently in the solution document. So based on the multi-segment pseudo wires. It has been brought into attention multiple times that we could actually also model the transport based on the EVPNs. And nowadays that you can actually also have the control word, it's recommended in the 8214. And or then we could come up with something new that Norm gave a name as a DETNET wire. So and this seems to be a sticky point, so we need to kind of make a decision which way we go in the future. So next slide. And if you keep in mind the layering and the services that the data plane needs to provide for the netted service layer, so one of the key functions that we need is going to be the sequence number, so that we have the possibility of finding splitting flows and finding the duplicates. So that's about the why we keep up pushing this sequence numbering into DETNET flows. It was pointed out that the current solution document assumes that the sequence number is a flat number space that just like consumes the whole number space. So like if it's a 16-bit, it has the full 64,000 numbers usable. But in our attempt to reuse existing 4448, it was pointed out rightfully that the 0 is a reset number. It's kind of we missed. So, and if we in the future want to interwork in any way with the existing layer 2 technologies that already deploy DETNET services and the duplicate elimination, things like that, they all assume the full sequence number space. So if we end up using a technology that has reserved numbers like 0, interworking with those is going to be very, very challenging. So the question number 4 that I have relates to this how we encode the sequence number into DETNET flows is like so that and this is specifically in the context of MPLS-based solution and reusing the existing standard that we have for EVPNs and the pseudo wires, which is basically RFC 4448, is that actually usable? So if we need to define a new control word type solution that would fit, for example, into pseudo wires or EVPN, whatever we chose for, should we go there and just define our own, let's say, control word type of solution? And if we go that route, will that be an issue when we look into modeling this solution over pseudo wires or EVPN? So basically, do we try to reuse existing standard on this regard, or just go for and design something of our own? That's the number 4 question. and then depending on the answer, if we go for a new control word, so question 5, will that implicitly mean that what we are going to define is not pseudo-wire, it's not EVPN, but it's something different? And are we fine with that? And if you want to peek into the next question is going to be, what is the actual technology? So should we go for the, so number 6 would be the, whether we go for pseudo wires or whether we go for EVPN or something else. Okay, so question 4 first.
We actually have someone at the mic. I'm not sure if he wants to ask a question.
Okay.
4, 5, or 6, or something completely different.
No, I mean, I thought we were
Stuart,
dealing
by the
with
way.
these slide by slide, so it's Stuart again. So the first question I've got to ask you is, do you think you need to put anything other than Ethernet over this service? Because if you think that we might have to carry some other legacy service, then there'd be a lot to be said for staying with the pseudo-wire format, at least the format as emitted by the TPE, because lots of silicon can already do those sorts of things. The issue of skip 0 is irritating, but it's not catastrophic, right? There are you can do it. You just have to recognize that you've got 0 and you've got 1 less than 64,000 in your sequence number, and the thing just skips it on the one side and interprets it differently if it ever sees one. So I don't think that's catastrophic in terms of continuing to use 4448. In terms of using the EVPN system, you have to remember that there is nothing even remotely analogous to the SPE. So I'm not sure what is driving you to that, but there certainly is nothing analogous to the SPE. But really, the SPE is the wrong concept. I think we need to think about replicators and eliminators put in the network, and I think that would be a better approach to introduce a different object.
Stuart, a clarifying question. It sounds like you're advocating or saying that pseudo-wire constructs really aren't providing us a lot of value here, and in fact may be wrong. You're saying that, sorry, my turn not to lean into the mic. You're saying that pseudo-wires aren't providing a lot of value, number 1, and number 2, may be even the wrong construct to be using.
Certainly SPEs are the wrong construct.
Which is the whole reason we went with
pseudo-wires. Right. But whether TPEs are the right construct, I don't know. And that will depend on whether you want to carry other wire types besides Ethernet across this service with these reliability characteristics. And I don't know the answer to that question. If you do, there'd be a lot to be said for staying with the TPE design and just having a different object in the network that's not an SPE.
Lenny, do you want to respond, or should we go to the next question?
So we look into Ethernet as a payload type and the IP as or packet as a payload type. So for the existing pseudo wires, for the latter we look into RFC 6658. That gives us that possibility of carrying any packet over the pseudo wires. So that was kind of the for that one. Regarding the SPE discussion, that's basically the question number 7, and I think that Norm is going to have a lot to say about the functions that we had for the SPE when it comes to replication and elimination. So that's most part of the next discussion. Skipping, reusing the 4448 and 0 not being part of it, and that's not being catastrophic. I myself kind of agree on that. The issue really is around what happens with the interworking with the existing technologies. So
So just do it again. Existing stuff would work nicely, wouldn't it? With 4448, you could take an existing TPE and it would emit packets that would go into your network.
So that's more about the reusing. So the existing technologies, they have the sequence number already embedded in those payloads, and if we want to keep the replication elimination working on, we actually the TPE would take the sequence number and use that sequence number somewhere in the payload. So it kind of touches that point. So, but I let Norm to say around that if he's on the mic.
So Pat Taylor. So Stuart, the point is it's on the slide, but basically, if you're using this to carry the layer two technologies, then if you don't skip 0, you can carry the same. You can use the same serial number at layer 2 and in the pseudowire encapsulation. But if you skip it, then that will diverge because the underlying layer 2 isn't skipping 0.
Yeah, this is Norm Finn. Let me say something about the skipping 0. If it can be an issue. If the result is that every 64K packet gets delivered twice, that may or may not be a disaster. It depends on the application. If the result is that every 64,000 packets, you drop a packet and it doesn't get delivered, that's way, way, way worse than our goal for that would be terrible. Okay, so it has to be dealt with somehow. We have to figure out what it's going to do. Okay, I would be reluctant to deliver them twice because that's for some applications that's not going to be, you know, that if the packet is flip the switch and they need this reliability because they have a really stupid protocol that says flip the switch instead of set it to on or set it to off, then that can be a disaster. So we got to deal with it. Okay, and it doesn't matter to me a whole lot whether we're reusing whether the point is being able to reuse documents or being able to reuse some gates. I think it's great if we can reuse some gates. I think it's nice if we can reuse documents, but we got to settle it.
We should figure out what the right technical solution is, and then have our documents back it up, not be driven because of being artificially constrained by documents. Before getting to the queue, I just want to ask Yanni, do the authors have a position on this question?
So, okay, so this doesn't represent the whole team. So this represents me. So I don't have an issue defining a new thing. So reusing documents is okay, but the what Norm says about reusing the gates and the existing solution. So having a counter to implementation, not to skip 0, might be actually an easier solution at the end from the hardware point of view. So,
yeah, Norm Finn, this is obviously a rat hole because it's so easy to understand. Everybody's got an opinion. I believe that one of the things that we really need to do is that there are a lot of deployed applications there. We want to capture those applications and move them to bigger, better networks. And to capture those applications, 0 is just as good a serial number as anything else. It does not mean don't do thing.
So you're just to be clear, you're saying we should allow for 0, applies some changes.
It's just another sequence number.
Great, thank you, Pascal.
We have a clearly delineated architecture where we've got a device somewhere at the edge of the network or some middle point in the network that does the sequencing, and that device talks layer to layer to a device that does elimination. That's very clear in the architecture. And putting any semantics for the lower layer about what those two guys say when they set up a sequence number is a layer violation. And that's why we're hitting all those problems. We should leave those two guys put whatever they want, and like we said, it depends on the semantics. And even if they want to put it as a non-sequential number, I mean, to defeat against attacks or whatever, They should have their own place where they can put this sequence, and the rest of the world should see that as an opaque that just blindly transport it. We should not be talking about the upper layer semantics in this room.
Yeah, we're just to be clear, the point is if we don't skip, if we allow 0, we might be able to send less bits on the wire, and that if we have to skip 0, it means we definitely have to add some bits on the wire. So this is an optimization question, not whether or not we're restricting what the user of DETNet can carry or consent.
If you can transport an opaque all the way, whether you encode it with zeros or not zeros, it's okay. But it has to be an opaque for the lower layers.
Mm.
Otherwise, we'll hit all kinds of problems.
Andy Malice, speaking as PAL's co-chair, there's no reason in the world why we cannot define a new DETNet pseudowire with the behavior that 0 is included in the sequence space.
Okay.
Okay, so I think we have 2 directions to go to resolve here. The first is, we want to be constrained with the existing semantics of the pseudowire definition that requires skipping of 0. The sense I'm getting from the discussion is that we don't want to be constrained to skip 0, and that 0 should be treated as just another value.
Yep. Okay.
I'd like to see if anyone disagrees. So I don't. Hums don't work for my ears, so I'm going to ask people to raise hands just to get a feel for the room. Does anyone object to that path of allowing 0, using 0 as a valid value? The implication is we're doing something a little different than what is out there right now. No objections.
Okay, good.
Stuart, if you out at the mic, I can't hear him. No one can. It doesn't go in the record. So Stuart's coming. Mike.
Stuart, yes, just define another pseudowire and it will work. You want to think about whether you want to pick up all the other characteristics of the design, but yes, that will just work. It's easy to do.
So now we get to the next question, which is, do we care if we model this as a pseudowire, as an EVPN, or as something else?
Can I just go back a bit though? All right, just slightly. Pseudowires use 16-bit sequence numbers. All right, well, that's the current design. People were talking about the sequence numbers needed by the underlaying service. Isn't that possibly a different sort of number space? I mean, it could be 8 bits or it could be 32 bits. So I think perhaps we shouldn't get the two muddled up.
Agreed. We shouldn't get too wrapped up in it.
But Pascal, again, the semantics of what the sequencer and the eliminator use, and there can be multiple applications and doing very different things. One could jump every 2 other bits. One could encode it in some weird fashion to protect against attacks. The lower layers should not depend on what the upper layer does. With number of bits, skipping 0, whatever that is, that should be completely layered, differentiated.
I think we all agree on that. I'm going to cut the line on that discussion. We have a lot of other questions to go through, and we want to leave some time for Norm.
Yes.
So it would be good to get to this question.
Yep. The number 6 is the big one. It's kind of going to shape a lot of what happens in next revisions of the document. And so basically, whether we keep up with the pseudowire-based approach that we have today, or we kind of start keeping EVPNs in our minds, or then we just go a different route. And so I just want to kind of point out that the kind of discussion between pseudowires and EVPN, and when you look in the actual encoding on wire, for the pipeline point of view, they look the same. So the
Stuart, yes, EVPNs use pseudowires to carry their data payload.
I think this is the point that Yoni was just making is while the wire format's the same, the documentation is quite different. And
Well, yes.
so this is a documentation and modeling question more than a wire format discussion. Asked question, but then went around. So let's move on. Does anyone else want to comment on this topic? Norm, you're up.
Yeah, Norm Finn. I tend to go towards wanting to do just DETNET wire and define what that is. And one was the control word that we just settled. The other is that if I look at what does TSN want from DETNET, okay, which is one important consideration, not the only one, certainly. We do not, TSN does not always want an Ethernet connection. Thank you very much. Okay. We want a routed connection. Okay. One of our problems is that you can't make a bridged network big enough. So giving us a pseudo wire that provides an Ethernet connection that connects these two clouds is not necessarily what we want. Okay. We don't want to expand the volume of the broadcast space. Okay. So the pseudo wire, the thing after the control word, I believe I think I'd like to see it as not necessarily 12 bytes of MAC address being the next thing after the control word.
You're focusing on the third option that Yoni mentioned, which is we should be defining what the DETNET data plane is and not worry about reusing anyone else's terminology of pseudo wire or EVPN. Those are just ways of describing the same thing on the wire. We should just be worried about focus on the wire.
Yeah, it's a way to attract other people's baggage, other people's arguments.
Yeah, and one modification to that, if we go that way, I wouldn't call it a DETNET wire. I would just call it the DETNET data plane. And because just to be clear that we're focusing on the data plane, not a new pseudo wire, not a new EVPN. It's just DETNET.
So Stuart, yes, I agree with you. EVPNs don't have any in-network construct, which you need, so you're going to be modifying EVPNs anyway. Greg and I are having a semantic argument over whether EVPNs use pseudo wires or not, but that's a different matter. The fact is that it's still not a perfect fit because EVPNs don't have the other construct you need, which is in-network replication and elimination. So I think the right thing to do is to define the right structure to carry things. Maybe use the OAM stuff that we already have and make it easy to use those sorts of things, but design the right thing for the job.
Right. Okay. We're just to be clear, we're not talking about a new data plane here. We're talking about reusing the existing data plane. It's just how we describe it. So the sense of the conversation, at least I'm taking away, is that there is agreement among those who have spoken. Excuse me, more coffee, please. Spoken is that we shouldn't worry about tied to the existing modeling. We should just focus on the data plane and describe just the data plane and whatever makes sense to bring into the document, but not be constrained by a pseudo wire construct or even an EVPN construct. Are there any objections to that reading of the room? So there appear to be no objections.
Okay.
So I think this could be settled. We should document that way as the resolution. The notes will do that, and we can move on.
Yeah. So, okay. Number 7 question, I'll skip that because we'll figure out that later on.
I don't see a number 7 in the slides.
No, it is. It's last line. It's the
Oh,
answer.
sorry. I was reading question 6.
Yeah. So, I mean, there's quite a bit long road to actually for modeling of the relays and stuff. So I rather see some documents evolving before we go for this. So okay. So for my part, I got a very good, clear guidance where to go next. So thank you.
Yeah, Yoni, on number 7, as part of once you have the document cleaned up, if it makes sense to propose something there, context cleaned up, please do so. obviously use the list.
Yes. Thank you.
Pascal Tubert-Uni, I'll come back to your question 7 in my presentation.
Great. All right. Thank you. I'll switch off this one.
No, I think I'm sorted. Norm Finn. Wait. Oh, I wasn't counting on doing my slides in addition to unis. These are mostly DP solution stuff.
You have the whole slides.
These are slides we got.
These are the slides we received from you.
I had
Did you send us the wrong slides?
these aren't the slides for the data plane for the bounded latency.
No, that's later.
That's later.
You're doing pref now.
Yes. Oh, okay.
If you don't want to talk about
No,
pref,
that's fine. I
that's
can do
fine
this.
with me.
I thought we were doing uni slides instead. I'll be glad to do this, and I'll be quick.
We did these already. You just jump to the pref discussion.
Yes. We've taken care of that. We've taken care. Oh, I had a question because it's been brought up in the group about load sharing. Let's go to the diagram. Where did I have my diagram? Here we are. Imagine that between where it says rep and a limb, the two dotted lines. I'm going to use the diagram from another slide. Imagine from the between rep and a limb, we have two slow links. So I have two 100 megabit links, and I have a 150 megabit flow. Okay. We have these convenient serial numbers on them. We could split that flow into two and send it on the two wires, and use two DETNet flows and recombine them at the other side and manage to get a single flow over two slow wires or 5 slow wires or whatever. And we have the serial numbers in the packet, so that wouldn't be too hard to do. And do we want to add that and make that part of DETNet and its architecture? So that is
Norm, I have a
a
suggestion.
question.
Let's look at what our pref solution is, then ask this question again.
That's fine with me. That's fine with me. Are we ready?
So,
Okay.
So we'll remember to bring that up once we have a pref solution.
Okay.
We did this one already.
We did this.
There we go.
Aggregation encapsulation techniques. And this is one of the reasons why I argued for let's do the DETNet thing, which is now a DETNet data plane, not necessarily grabbing onto pseudowires. For scalability, we need to aggregate. Is there a no? Okay. For scalability, we need to aggregate flows. Okay, we can't have the backbone knowing about every single flow. We want to put a bunch of flows into a bigger flow. Imagine that we've aggregated all those flows on the left so that they can be delivered on the right as separate flows again.
We already have established that layering is going to be part of our solution.
Of course.
So is
What-
there something different here that you're talking about?
Only that I'm talking about that you may have a control word on the outside and another control word inside of that, because I'm doing 2 layers of replication and elimination. If that's a given, when we were tied to pseudo wires, that's kind of awkward. If we're not tied to pseudo wires and that's understood, that's all I wanted to hear.
I think that's a good thing to document that that's expected. I can't remember which document it was that talked about being able to run layers of DETNet for aggregation purposes.
Yes, I believe the architecture does.
Yeah, we explicitly had that in there from a scaling standpoint.
Fantastic. It's also been suggested that we don't need intermediate nodes that do replication and elimination. Do the replication and elimination only at the ends. Okay? Don't do them in the middle. I wanted to give the basic use case for why replication and elimination in the middle is a nice thing to have. This diagram was shown to me by a person who does industrial networks. In industry as well as service providers, you can have a big ring with little rings attached to it. There are times when you need to break the main ring to modify the topology. You want to add some little rings or delete some things, okay? And you need to have planned outages. In a large network like this, the fact that you're doing planned outages means that having 2 failures is not unusual. And in particular, if I need to break the main ring where the big blue bar is, I have to be sure that there is no little ring broken, for example, the red bar in the upper right. I have to make sure that all of those networks are clean before I make my main break, and I have to hope that nothing in a small ring will break while I've got the main ring broken. Okay, this is a very practical situation. They can't shut down the whole plant in order to make changes to the network. That's just not an option for them. If you have the intermediate replication points at each point where the rings join, the little rings join the main ring, then you can have 2 failures in the network. You can, in fact, you can have multiple failures. You can have a failure in any small ring. You can have a failure in the main ring, and you can still get the data through. So that's, I think, a requirement. So I think that's why we need the intermediate replication and elimination points.
Loa Anderson, I take your point. The question on this picture, if there is a break in the small ring to the upper right, wouldn't that ring turn the traffic around the other way? So instead going to
what I've shown here is 2 end-to-end paths. I'm not talking, remember, DETNET does not respond to a failure by creating a new path. I simply have the 2 paths, and I see the packets, and I throw away the extras.
I understand that it's in a ring technology would actually turn the traffic around.
I'm drawing a ring topology, not a ring.
So it's not the real
I'm not talking about a ring protocol that heals rings and turns things around and reverses stuff.
So this is not a ring topology in the sense of RMR or shared ring protection.
Correct.
It's just a topology that is okay.
Yes.
Norm, as a heads up, you're talking to a group that's dealt with rings and transport protection for a long, long time.
Yes.
So you may be triggering responses and thoughts that you don't anticipate because of these words. Most of us are really, really familiar with lots of ring protection solutions. For those people, he wants to do 1+1 end-to-end protection, not ring protection. So even though you're saying you got rings, you're not doing ring protection in the parlance of those who've been doing transport.
Exactly right. Thank you.
Kiriti Compella. Yep. So is the suggestion that you're making that when the traffic on the red path enters the small ring to the top right, it's replicated both up and down, so that when you have that red cut, it will be, is that the goal? Is that where you're going?
Yeah, actually, the source is down at the lower left.
Sure.
It goes both ways around the ring. The 2 squares each replicate the packets in both directions.
Okay, got it.
Okay,
yep.
One of which gets eliminated as they crisscross. Those get eliminated. Then they go around the big ring all the way around and crisscross again. One of them gets eliminated. They go around the little ring. Yeah.
Yeah, I'm not sure that's really what we want to do here. We've been talking about end-to-end protection, not a multi-ring.
I've not been talking about end-to-end protection. I've had the ladder diagram in the architecture from day one. The ladder has been with the intermediate elimination has been in the architecture from day one and talked about in the architecture.
All right, well, we'll have to figure out how to map these into the existing constructs that we have and figure out whether or not there's actually anything new here.
Well, that's what DP Sol has been doing.
Yeah.
Yeah.
Pascal Tuber, I thought we just said, let's define what DETNET is, and then we'll see DETNET over foo, right? So this is perfect. We define something which does that, and then we do it over foo.
Well, we were talking about how we document it. From a data plane standpoint, it was pretty much the same thing. But let's see where we end up.
Well, you just said this, right? We see what we want, and this is what we want. One of those things we do want. And then if we can optimize, something like the sequence counter or this on this particular layer 2 lower layer technology, we'll do it. If we can't, we'll have a header for us.
It's a little hard to define a technology from a slide, so we really have to get into the documents and understand what's really there.
Well, let me make it clear. That's what's in there now. That's what's in all of the documents right now. This isn't a novelty.
The funny thing is I barely heard you. So the point that Karidi made was that we have to really eat the mic. So sorry about that.
So there is one other question that's been pointed out. This is an example of a node on a ring that has an attached end station out there, attached host, and I want to eliminate the duplicates. And this is a ring, so I'm going to have packets coming in from both directions. Okay? I want to pass the packets in both directions, let them still go on around the ring, but I want to only deliver one to the end station. It's really easy in a one-chip router where one thing processes every packet to tell which one came in first and pass the first one that came in out the port. It has been pointed out by people that if I have a federated router with a bunch of line cards, and the way I've built this router is that absolutely all decisions are made in the ingress line card, and the egress line cards are completely stupid and just queue up packets for output, that I can't really do this. Okay? Well, and therefore we need to get rid of this thing. Okay? So this is fairly simple. There are ways around this. Yes, we could say, I'm not able to do that. You can only do elimination on input. So we'll go ahead and pass the packets on to the next guy and let him do the elimination. I don't think that's great for bandwidth. There are cases where you get at least 3 copies on a wire, which is not a good idea. So a number of potential solutions are possible. I would suggest that a right solution would be at most put a note in there that said, make sure if you care that to watch out for this problem.
Kiriti Kampela. I think we should put down what we want the box to do and not how it's architected. And if the box is stupid, don't use it.
I'm perfectly. That sounds good to me.
And actually, it's Lou, Norm. That's actually really the point I was getting at. Is that the function you're talking about from a box standpoint really is unaware that you're talking over a ring.
That's right.
It really is. And I'm blanking on the term. I wrote the document, but I'm just blanking on the term of what we've called it in the past. But we have whether you're modeling it as an end-to-end recovery, LSP recovery, or a segment recovery, you have a point that does the replication and a point that does the recovery. And from a box standpoint, whether that's over a ring topology or a mesh topology, a tree topology, who cares?
Of course,
And you can have net, and I completely agree. you can have these nested one within the other. So you can have one replication point going to another point in the network that has another replication point, and then them all being merged back together.
I understand this. Where this came from is that people who are doing elimination today typically think of a thing in the center of the box that if it sees the second copy, it throws away, and then it does the forwarding. The document that we have is very explicit that you do your forwarding and then you do the elimination just before output. That's not the way a lot of people do this similar things today, and they find that a shock. And I have had 2 people at this meeting and several and many people over the last 3 years come and say, "Oh, wait a minute, this is screwed up. I have to." And yes, it's more if you do it in one thing in the center of your box, you have to think about things, and you have to emulate that behavior, and that's not trivial. So if we make it clear what we want to do, I'm cool with that.
And to be clear, you're saying what you want to do on a box level, not an interface level.
Yeah.
And if someone chooses to implement it in the center of the box, great. If they choose to implement it at an edge, an interface, that's
right.
Great.
But what we specify is the behavior we need.
Right, which will not be it'll be in the context of a box.
Right. Exactly right.
So Stuart, I think the first thing is we should separate replicators and eliminators. They're separate animals that do separate things. Sometimes it's useful to have both in a box. Sometimes it's useful to have just one in a box.
Correct.
So we should architecturally split them out and talk to them as separate things. The control plane will need to know about them as separate things.
It is.
They may be right. So that's the first thing. So there's been some confusion then in the discussion about whether they are separate or not, and certainly it didn't come out in the solutions document to me that they were separate objects. So the second thing is that it seems intrinsically that a replicator is an ingress function and an eliminator is an egress function. If you choose to execute it some other way inside your implementation, fine. But essentially, the right place to do elimination is on egress. The right place to do replication is on ingress. Inside your box, you may have some extra packets, but hey, that's just inside your box. That may burn up a little bit of backplane bandwidth, but so what?
Stuart, I think we just took the decision to not describe the internal behavior, and that and we're going to describe it as a box function, and it's up to the box to decide how they want to implement it.
Hang on a second, you're going to have gang models and all sorts of things to get these things to work.
I couldn't hear you, Stuart.
Luke, I have to take a little exception to that, okay? The easiest way to describe the behavior is to draw the elimination function on the output, okay? If you describe it in terms of the box, you wind up with 17 times more text, and it's very confusing. So I would describe it with the functions there and say, however you do it, this is the result you want.
So if the normative text describes the behavior on a box, that's fine. And then the informative, the non-normative part, uses an example that describes it as in a particular instantiation.
Right.
That's fine. But we have to make sure our normative text is on the device, and the informative you can describe it any way you'd like.
We absolutely must not require you to put the functions in this place in your box.
Exactly.
Absolutely right.
Thomas Eckert. So let me take both sides of the argument. I fully agree with Stuart that we'll not be able to troubleshoot and do anything without more specific.
Can you lean in a little bit more? I'm sorry.
Oh. Sorry. No, it's really hard with these microphones. So I'm coming from multicast side, and I haven't seen a single Yang model or anything else that actually goes into the details like ingress and egress, and especially we've built this new really crazy cool forwarding plane called Beer, and internal behavior of the box was never exposed anywhere, and I'm just waiting for these to become problems in operations. But from the perspective of how have we done this in other groups, how can we avoid talking about platform stuff, I think you're completely on the right track. Are you on the right track of getting something successfully easy deployed? That's a totally different question.
Yeah, I would suggest you take a look at branch nodes and PLRs, point of local repair, in FRR and in segment recovery and end-to-end recovery, because that's really what we're modeling. So the existing technology we're looking at isn't IP multicast, but more about the MPLS protection and recovery mechanisms that are widely deployed.
Well, IPFRR doesn't have this concept. Stuart, IPFRR doesn't have that concept. Is this one of the techniques you're using in? Because there's no elimination normally applied in an FRR system.
You have PLRs; they don't operate packet by packet. So from a concept standpoint, we have pieces that have modeled this before that we're patterning after.
I think this is a longer conversation than we got time for here. But
right. Just remember, there's MPLS out there and there's GMPLS out there, and we're going to build on those.
Maybe one way is really to start proposing text, and I think that there are certainly for the elimination a lot of not prior knowledge from both technologies that Norm was mentioning, like 802 CB, and also application layer redundancy removal. And if you simply start from the perspective of what are the diagnostics that operators want to have, express them through a Yang model, then you're already implying certain forwarding plane functionalities that you need to support.
Okay. Unfortunately, you don't have any proposals yet on such Yang models, and it would be great to start seeing some proposals. And if you want to leverage some of the background that you have and bring that in, that would actually be a huge help.
Yeah. I had one totally related but different question. How about the just insertion of sequence numbers? Are we in DETNET all just assuming they already perfectly exist, or is that another forwarding plane function?
That's part of the encapsulation function that Yoni was talking about. We're going to insert them unless there's a technology that we can piggyback on.
So that would never be decoupled. That should always be only done in the encapsulation side.
Only done in the
encapsulation side. That it's an integral part of the encapsulation and not come later.
Well, except for the thing that he had in the middle that was doing aggregation. That needs to do it as well.
Right.
You can do layering, so these can be nested.
Okay, thanks.
We actually are ridiculously over time.
Yeah,
this
so
is
let's
good discussion.
let
so
me,
I'd like to take I'd like to take David's comment and then see if we can wrap this up.
Okay.
Yeah.
This is probably not the right side to ask.
David Black,
can
who are
we go
you?
back one or two? In essence, the question I want to ask is, I'm trying to understand this from a requirements perspective. And what's up here looks like trying to design about 3 different implementations. I'm lost in the weeds. So, simple question. Suppose I replicate and I fail to eliminate and both packets go forward. What happens?
Then you violated the specification.
Okay, that's a must. That goes in the doc. This is all possible advice to implementers about how they might meet that must. But your normative text says you must eliminate, and if you can't do it, sorry, go play somebody else's game.
I apologize for making this more complicated than it needed to be. I think we've got adamant agreement here that we specify what we need to do, and that's fine.
Right, and in particular, with respect to the prior discussion, what I essentially said is that at the egress interface, duplicates must not happen.
Absolutely. So it sounds like 7 is just fine.
State the requirement and let implementers figure out how to meet it.
Right, and it's perfectly okay to have narrative that describes a specific implementation if it helps make it easier for others to implement. Thank you. So I'd like to ask the next 3 presenters to shorten their time by 5 minutes, and that will put us back on schedule. So 10 minutes, please. 11:15. Oops, sorry.
Okay, my name is Balázs Varga. I will speak about the information model and data model updates. This presentation is about the discussion we had since the last IETF meeting in Prague. It will show very shortly what updates we have made in the drafts, and we'll also highlight the next steps. So in the last IETF meeting in Prague, we had just one information model, and it was the flow information model. During that meeting and also afterwards, there were discussion about service model and configuration model related stuff to be included in the workgroup documents. And we had quite lengthy discussion with the authors of this draft and also the other draft you will see very shortly. And in order to define what type of data models we need for DETNET, we have just looked to some IETF specification regarding information model and data model. They are described in 3444, and information models describe on a high level and pretty much implementation and protocol agnostic, the management objects. However, data models provide a much lower level of details, and they are also protocol specific and pointing exactly how to configure stuff. The other definition we have used is regarding the service models. I think these are very essential part, and this is a very specific type of data model, because it is practically describing in an independent way and technology independent what service is provided for the customers. There are two types: the customer service model. This is something that is shared between the customer and the network operator. And it is just having a high-level description of the service. And that is what is used by the service providers in order to create the service delivery model, which consists all the details about the service, how to implement it on the network elements. And of course, we have also looked to the young definitions in order to find out what explicit stuff have to be done there. And based on the discussion, we have concluded that there are requirements for three types of data models: a service model, a flow model, and a configuration data model. The flow information model and the service information model is something that is shared between the customer and the network operator to define the service and the flow characteristics. And the configuration data model is something that is between the management and control plane entities and the network elements to define the configuration of those devices in detail. So that stuff was put in two different drafts. One is dealing with the service and the flow information model. This is what we have also updated to this meeting. And there was also a new draft created by our colleagues about the configuration model, which also includes some young specific stuff. Just to very shortly highlight the update in the flow information model draft, we had already, for the flow information, three group of attributes defined: the source, the destination, and the flow status. And now what we have added to the draft are some placeholders for the service information model. And there we have four group of information attributes. One is related to the ingress, one is related to the egress, one for the DETNET domain itself, and of course, there is also a status for the service that is provided. And the plans is practically to update those drafts. The configuration model draft is a version 0 draft. So there are also some part where we intend to update. And also in the flow information model, the service model specific stuff is something that we intend to update in the coming months. That's it. Any questions, comments?
Questions, comments? Okay, the last meeting we talked about that whether or not to adopt this document. At this point, we'd like to get people's feedback on whether it's time. How many people have read the document? It's a okay number, not great, not bad. How many people think that this document is a reasonable starting point for work in the working group on this activity in this area? Should we adopt? It's about, I'd say it's about the same. So it's an okay number. Actually, there are more in the back than, so I think we actually got more people saying we should adopt than read. That's always an interesting outcome. Thank you for the feedback. We'll confirm on the list. Pascal, you have 10 minutes.
Okay. 25 years ago, I was working with IBM on a transport layer for SNA, which was 90% of the networks at that time, and this extra new thing, which was called IP. And so what's interesting in this job is that a good number of lessons that you could learn at this time still apply today. And for example, one of the big lessons was writing to an LU 6.2, which was the SNA interface, was very, very complex, whereas writing to the IP socket was kind of easy. Several years later, I mean, SNA was there, then IP was there. If we want our technologies here to be very successful, we need to provide a very simple API to the upper layer applications, which means we need to define a transport that takes all the complexity of going over a DETNET link, as opposed to push all this complexity to the upper layer, to the application. At the moment, the big hassle we have in the field to move industrial applications, audio, video applications, etc., onto Ethernet is because those applications have to rewrite everything that we normally would place in the network, such as jitter elimination, in-order delivery, etc. And so some very big applications, they could migrate to Ethernet, but most of the industrial, automotive, and all sorts of things, applications still stick to serial cables, point-to-point or buses, because writing to a DETNET wire or something is just an Ethernet wire. It's so complex. You have to do all those functions which should not belong to the application, and because they don't exist anywhere else, they have to be pushed to the application. So what this document is looking at first is how can we provide a transport layer which gives to the application a simple API so as to use the deterministic network. And then we'll see that this transport, and it's another lesson learned from those times, at those times the transport I was talking about, the DETNET transport was frame relay. I was writing a frame relay transport terminal equipment. And trying to transport normal transport, layer 4 transports like TCP and UDP was a huge failure. And the reason is those frame relay networks implemented a function called CIR, Committed Information Right. And the committed information right is pretty much like the shapers we are talking about in DETNET. They will cut extra traffic. So what's going to happen on this network, what did happen on those networks with TCP is TCP was growing the window. And at some point, the CIR would just see too much throughput and would cut the data. And then the window would go down and traffic would look like a seesaw. Now, if you put TCP on the shapers that we are describing here, you'll get the exact same results because they're pretty much the same behavior as CIR. Now, if you want to put UDP on this kind of networks, depending on what the throughput of the application is, I'm giving you few bytes by few bytes by few bytes, each one encapsulated in a big UDP datagram, or I'm giving you like 10Ks and you have to slice them up in fragments. The overall bytes that are going to be sent on the network will vary dramatically for the same application throughput, meaning that I have a deterministic network, but I have a completely undeterministic feed into this network, which gives me an undeterministic result, right? So at some point you figure, okay, I cannot use the usual layer 4 transport that I'm used to on this deterministic network. I have to provide something which simplifies the application writing and makes the best use of the deterministic underlying topology. And that's basically what this document is. It's talking about providing an IETF sense transport so as to use properly the underneath DETNET transport services, right? And you see that part of what you have to do in this transport layer fits actually into what this group calls the service layer. And the rest is in the document. If I don't have more time, but
I think it would be really good to highlight any changes you think we should be doing in here, just so people are following, right, who may not have followed what you just said. The transport protocol, like think TCP, UDP, that layer, we're not going to do in this working group. That belongs in the TSV working group. What we'll do here is if there's any requirements that percolate down, we want to make sure that we have them appropriately covered. And so
Yes.
anything, if you could focus on those aspects.
This is, yes, exactly. That's what my
that would be
presentation is
great.
all about.
The one thing I'll say, and this is more as a contributor, there's been some really good work about talking about, I think it was actually done at Google, of taking TCP and replacing its flow control with allocation-based flow control. They have a paper that's on credits, and they reference earlier work where it was just straight allocation. And it won't, that work shouldn't suffer from what you're talking about. But
Yes,
this type of discussion, while it's really interesting to those of us who are working on DetNet, it actually belongs in TSV working group.
Yes, exactly. And one outcome is a discussion to basically split basically present what we wanted to achieve, and then work with TSV to make this separation. What happens where? That's what I'm getting at. But I also would wish
we have the separation. Just we're not doing the transport protocols here. Full stop. If you can,
we are describing transport layer functionality in our documents today. So well,
I think maybe that's a subjective thing.
That's what we want to determine.
David Black, as speaking to TSVWG chair, I think there's still a little bit of separation to be done, because I see some things being labeled transport that I'm not sure are. In particular, I see some link level flow control between the host and the first hop switch router, which does not sound like transport to me. Happy to take congestion control, but link-based flow control is something else.
I think we agree. I'm not sure about that. Necessarily agree with what's written in the document, but I think you and I agree.
Okay, so
As chairs.
okay, cool. And so I'm standing up here in part because Pascal put TCWG in the title, and sort of it was sent over to TCWG, and we looked at it and couldn't quite figure out what's going on. I said that at the very least, there is link level flow control in this doc. That almost certainly stays here. The high level transport protocol, which is okay, figuring out how the application thinks about the fact that this network is ticking, and at every tick you can send at most 5K. That's starting to sound like more of a transport protocol where we can have a direct discussion about where and how to work on it.
You know, the one area that I think might be confusing is something like pref, and whether that is something you do end to end at the transport protocol like you do with TCP retransmits, or is it something that gets in the
what I thought I heard about 15 minutes ago was that your routers do that, and if the router gets it wrong, the router's broke, try again.
Right, and that's the point I was getting at. Is that
and that's not a transport function. That's the moral equivalent of the class of ring protection mechanism you find in you find in some of these in some of these interconnects.
Yeah, agreed. But the problem is in routing area we call that transport.
Yeah, well, I'm sorry we can't. I'm sorry we don't have enough words in the English language. The fact you call it transport does not make it my problem by definition.
Well, the point, David, is we have layered stuff, and this is in the. Oh, sorry.
Yeah.
Okay. So in any case, we're down in the weeds. What I'd like to see is some teasing out of what would be transport, as the IETF uses that term for transport area, and what needs to be solved here, because it's fundamentally lashed to the components that make up a DetNet network, be that the links or some of the fancy function in the nodes like pref.
By the way, David, the replication and elimination that can be in routers or in end nodes, but I agree that it's regardless of which it's being done at. For DetNet, it's at layer 3, and TSN does it at layer 2 as well. So yeah, it's not layer 4.
Yeah. So question to David. So I mean, we've done tunneling across flow controlled stuff, right? So I'm just trying to understand your logic about. It sounded as if if it's not end-to-end flow control reliability, it's out of TSV, but that's not true for the technologies we've done, right? Like tunnels that have flow control.
Don't cover the whole thing.
Which I don't know what it is because now I'm lost.
Okay, so we're going to need to have the presenter present what he thinks impacts this group. He really is out of time, but so we'll ask him to go as quickly as possible.
Right. So the initial first thing I would like people to read the draft and make their own mind. But the thing which definitely impacts this group is that we have to have an architecture which covers the things we are talking about here. And then once we agree on the architecture, then we can always decide, because we have this layered architecture, and basically going down the sub-layers of the service thing, we have to decide where the transport is and where this group is. So I will basically go into 3 slides or 4 slides I have here, where I'm suggesting tiny deltas to the current architecture document. Left is the current, and right is the new thing. So, well, the first thing I want to mention here is mostly the introduction of load sharing, which is pretty much echoing what Norm was saying. Probably I think we need to express better and position better what load sharing is. I'm not saying that every protocol that DETNET is producing has to do load sharing, right? But we still need to position it in the architecture.
Yeah, again, be careful to, rather than inventing new terms, please use terms that are used in the area. So we have ECMP, bundles, lags, things like that.
Yes, I mean, let's work with the working group on how we call things, right? So I have this delta and we can tune it, or just, I would like this group today to accept some deltas into the architecture so as to enable the features that this draft presents.
Rather than go through the details, why don't we, if you haven't already proposed them on list, propose it on list, and we should discuss it there.
Okay. Can I discuss still the layering a little bit? There are 2 slides. You know, this is the drawing that Uni has been presenting. And part of the discussion is which layers do we really have, and are we missing some in the architecture? Do we discuss that here? Because
we're really out of time.
Oh. So. Okay.
So this is a heads up that this discussion's coming to the list.
Okay, let me just. So basically, if you go through the slides, I will stop
Actually,
there.
I'm going to bring up something that Deborah suggested, and we were going to bring it up at the end. She suggested that it might make sense to think about an interim meeting, maybe mid-January, somewhere around there. I was thinking that would just cover data plane. So we'd look for an update of the data plane document and then plan for an interim to discuss that. But perhaps this is an additional topic to add into that, is to make sure that see if we can cover any issues we have in the architecture and wrap that up. So that would be a 2-topic interim that we should be considering and discussing on the list. But Pascal, please don't wait for that. Please bring the issues up on the list and drive the discussion there. Norm, now you're back.
I'm going to be very quick because I want to hear from Jean-Yves. I'll skip over this. The last 2 lines are important. We've not spent nearly as much time because the 1+1 redundancy requires fiddling around with the encapsulations and data plane. We've done an awful lot of thought on that. We haven't talked much about the main feature, which is the bounded latency and zero congestion loss, and how to do that. We have to be able to get accurate, not approximate computation of the worst case latency and how much buffer space you need to go along with that to ensure zero congestion loss. Without accurate numbers, it doesn't work. So, people are implementing this stuff. People are shipping a lot of product right now, not a lot, but some, to the TSN specifications, the 802.1 TSN specifications. Almost every box that implements this stuff is also a router. They aren't just switches, just bridges. They are routers, and they're implementing this stuff. So it would be nice for an RFC to be able to call out and say, yes, you can do this. This is one of the queuing techniques that are suitable for DETNET. It would be nice to be able to say, here's the Yang model that includes several choices. Among your choices are the TSN queuing stuff. Right now, that's practically impossible to do. So I'm telling you that there's a project that has passed its first hurdle for becoming a project. It's still got a long ways to go, to provide a document that gives a reference point so that you can say, I want you to use that particular queuing technology. So that's coming. I wrote a draft. The original purpose of this draft was to be able to reference that, so we could do that. I'm going to speak the unspeakable word, int_serve. We've done this. We've done this before. It's called int_serve. It really is. We need to be able to make use of that stuff. I would hope this draft would become, with some other, maybe somebody else needs to be the lead on this. This draft would become the document that says the way you get the zero congestion loss is that you use one of the following technologies to do your queuing. And these are the issues you have to deal with. Here is a common language so that you can talk about these different techniques, so that you can do the network calculus and figure out what you need to get the goals that we want to do. And so I consider this now an introduction to Jean-Yves.
Thank you. What we really would need from the working group is a draft that says, here's the Yang model to configure a DETNET service. And that DETNET service gives some abstract service parameters. And then we could have this document says, here's how you can go implement those abstract service parameters.
Yes.
But we're chartered to deliver a Yang model to describe a DETNET service. We don't have any drafts yet. So hopefully take a look at this document, think about it, think about that during the next next presentation, and send some text, please. Okay, thank you.
Just one comment. There is a version 0 draft on the Yang model just recently before this meeting announced by our Huawei guys.
So highlight that, so send it to the list again, and think about presenting that at our next meeting. Thanks, Norm, for getting us back on schedule. Welcome.
So today I'll give a short introduction to a theory that was developed 15, 20 years ago for things that today we would call deterministic networking. The credit is to give essentially to Ronnie Cruz, who pioneered this, and other authors who have evangelized and added stuff. It has been developed for deterministic networking called int_serve and diff_serve. It has been used by people like Rock Guerin for int_serve and by Anna Charney for diff_serve. And it uses a language that's a bit different than from what we read in the DETNET document. So I thought it was a good idea today to bring that language into this audience. I was asked by Lou to explicitly say where it could be used. So based on my knowledge at that time, which was before I came here, this is what I wrote. I think the major interest would be to have an abstract definition of nodes that would not prescribe an implementation. When we do a Yang model, we have to export the internals of a node, and if we do that too much, we are sort of saying that any node would be a certain scheduler done by a certain company. That's certainly not what we want. So one of the things we can hope to get out of network calculus is a description that is a bit more general than simply saying a node has a maximum latency of so much. So let's dive into some of the technical components. The first concept that is used is the requirements to limit the flows that go into a network if you want to have zero congestion loss. One mathematical way of doing that is to express an arrival curve. An arrival curve is a function of time called alpha here. That means that over any time interval of duration t, the amount of data units, bits, bytes, or packets, if your packets are fixed size, that you can observe in any interval of that duration is bounded by the value of that function. And this has been typically used in the inserve and diffserve settings has been associated to leaky bucket or token bucket constraints that correspond to one affine curve if you have a simple leaky bucket shown here on the left.
I think you have a question at the mic. I don't know if you want to wait to the end.
You wait to the end. Okay. In the DETNET architecture, I could read that essentially the constraints we put on the flow are maximum number of packets and maximum size of packets, which could be used to derive a constraint over over a time interval t, which is the time over which we observe things in the DETNET setting, which gives that kind of curve. Right? So that kind of curve is in fact what you obtain when you impose that the curve you have is called subadditive, which is a required property. So that's the first element. Then once you put limits on the flows that go through a network, you also want to capture what your network nodes are doing to a flow. In the inserve context, the network nodes were inspired by generalized processor sharing and packet approximations of generalized process sharing. So you can view this as an attempt to put all of those schedulers, there were tens or perhaps hundreds of proposed schedulers that have similar properties in terms of latency and buffering, but different properties in terms of implementation complexity. So that's one attempt to generalize all these schedulers. So that's the key concept of network accuracy, I would say, in this context. So we say that a network element, it can be a router or it can be an entire cloud, offers a service curve if the following equation is true. If you count the accumulation of data units d of t at time t, it must be lower bounded by the formula that is given here. Now that looks like a very abstract formula. How is it declined for various examples? In the inserve and diffserve context, practically always the type of functions that were used for service curves are the ones shown in blue on this figure. They are called rate latency service curves. So they are piecewise linear. They have a latency of t and a rate of r. So many schedulers can be modeled as having this property. Practically all schedulers you find in Linux implementation today are of this type. And in all the schedulers that were defined, there's a bug here, it's not RFC 7000, it would be too young for such an RFC. It's RFC 2212 that has defined the specific model used in inserve, and it explicitly makes reference to something that can today be interpreted as this rate latency service curve. So it's one way to model, for example, the service received by high priority flow when there's no preemption. That's the easiest way to understand it. So a packet of this type, in such a scheduler, might be subject to a delay t, which is the max delay due to low priority traffic. And once it's served at a minimum rate r. But I insist today, this is a very simple way to think of such a rate latency service curve. But the interest of this is that many more sophisticated schedulers, such as deficit round robin, that give number of quanta to every flow, have a similar property. Of course, such schedulers have the property that they isolate flows. With deficit round robin and with all the weighted factoring schedulers, you are able to isolate a flow from an excess of traffic coming from another flow, which of course you would not have with a priority scheduler. Another interesting thing is that if anything you know about your node, if your node is too complex to be modeled in detail, for example, perhaps for some TSN nodes, the only thing you know is a worst case delay. So if you know something about the worst case delay, that's also a special case of a service curve. Now, admittedly not very interesting, but the interest is that it fits in a general framework. And I will say in a minute what that framework leads to. But before getting there, the very first things we can do when we have service curve and arrival curve is 3 bounds. The first bound is on backlog. Norm mentioned the need to quantify backlog and delay. So this is done once you have those curves. You take the horizontal deviation to obtain a bound on delay. So you draw a straight line at any place, and you take the max of what you get. That's what we can call the horizontal deviation between the arrival curve and the service curve, and that's a bound on the delay. Now, depending on whether your arrival curve and service curve properties are tight, if they are, this is a tight bound. Similarly for backlog in the vertical axis. And also it gives you a tight bound on the arrival curve at the output. So one of the well-known problems we have when we do deterministic networking is that even if we constrain a flow at its input to have some maximum burstiness or maximum number of packets per time interval, as soon as if it is asynchronous and it is sharing buffer with other flows, then this is no longer guaranteed at the output of any node. So the increase in burstiness can be obtained by the formula that's shown here. For example, that's a computation that was very frequently used in the past. If you assume the arrival curve you have is derived from a leaky bucket and the service curve is given by a rate latency service curve, then you have those explicit formulas. We find, for example, that the worst case delay bound is a function of the latency term of the scheduler plus a term that depends inversely on the burstiness of the flow, which is one of the parameters of the arrival curve, and inversely of the rate of the scheduler. It can also be used to quantify the increase in burstiness that you have when a flow is served in such a scheduler. Now, perhaps the main interesting result in the context of INSERV was this one. It is the concatenation property. This applies whenever you concatenate several service elements, nodes, or even clouds, and you assume that you do per flow guarantees. So you assume that each of the service elements is giving a service curve property to a flow. That does not apply if you do per class guarantees or aggregate guarantees. But if you do per flow, if the first network element offers a service curve beta 1 and the second beta 2, then you can forget about the details of this concatenation and model the whole thing as one network element that offers a service curve beta, which is given by this formula here that can be easily computed. This formula is called the mean plus convolution of the two service curves. For arbitrary function, it might be, it's an optimization problem to compute it, but for piecewise linear function, it's fairly simple. For example, for rate latency service curves, if you do the mean plus convolution of two rate latency service curves, you simply add up the latencies and you take the minimum of the rates. This translates into the following results that was well known by INSERV, and it's explicitly used in the computations that are done in RSVP. It's called pay bursts only once. I'm assuming here that I have a flow that is served by two network elements. The first one gives a per flow guarantee beta 1, service curve beta 1. The second one similarly with beta 2. Then I can do two things. I can compute bounded latency by summing up the two bounds. I will have a first formula, and this formula we see two things. We think that the burst parameters are affected by a factor 2. So in the worst case, you can have a delay at the first node and at the second node that is proportional to the burstiness of your flow. You also have an additional term that comes from the fact that the arrival curve into the second node is worse than it was in the first node. But because we know the concatenation result, we can abstract the entire sequence of elements by its mean plus convolution, and then we obtain a second bound, which now is tight, and this bound has the magical property that the burst parameter is affected by a factor 1. So that's why it's called pay bursts only once. It is not possible to have both the worst case delay in the first node and in the second node, because if you have it in the first node, then the scheduler will not be able to produce the worst case burstiness at the output. So this means, this will have implication I will discuss in a second. We also very frequently use the word shapers. This is used in different contexts with different meanings. In network calculus, a shaper is a device that forces a flow to have an arrival curve constraint. So if you have a flow generated by an application, it may not have the arrival curve constraint. So functions like Linux TC will offer you the possibility to make sure that the output sent on the network will be satisfying the arrival curve constraint. And one very famous way that was described by René Cruz is, for example, leaky bucket shapers. This was also developed in other contexts that delays the data until it's able to be controlled by this leaky bucket. Shapers are also very well understood in network calculus. So if a shaper has this mathematical property, which is also expressed by min plus convolution, which in particular implies that if we view a shaper itself as a network or service element, it delays data, so it has also a service curve property. Of course, it's doing much more than delaying the data, it's also shaping it. But if we're interested in a delay introduced by shaper, then we can simply use this formula to say that the shaper also is a service curve element with a service curve equal to the curve that it's shaping to. Another properties of shapers that was well known in the context of INSERV is this sort of miraculous transparency of reshaping very often in network nodes in order to control backlogs and delay and buffers, not delays. If we're interested in controlling delays, we can ignore what happens in the intermediate nodes. But if I want to size the buffer that is required at the second node on this figure, then I know that the worst case arrival that pattern for this flow is worse than at the origin of the source. So what is frequently done is to impose reshaping, and I believe this is done in many TSN implementations. Now, one legitimate question is, if you reshape, are you making the end-to-end delay bound worse? Are you potentially you are, because if some traffic is, if burstiness has been increased at the output of the first node, you delay things. But it turns out that if you do per flow shaping, per flow scheduling everywhere, this is not happening. So reshaping is for free, and I cannot resist. I know it's IETF non-compliant, but I cannot resist the math that is given here. You have the mathematical explanation on the last line of the formula here. On the left, you have the horizontal deviation between the arrival curve and the service curve of the entire stuff, which is the mean plus convolution of the three functions. Now, mean plus convolution is like a standard convolution. It commutes. You can change the order, which means the delay bound you obtain is the same if the shaper is put as the very first element. Now, if you have a source that is conforming with your constraint, if you shape it, then the shaper is transparent. So that's one of the results here. There are other bells and whistles that may need to be considered. In particular, if we would like to apply this in a DETNET setting, in particular, we may need to separate variable and fixed delays. Now, what are the implications on things like bounded latency, path computation? Well, one of them is whether we could do better than characterizing intermediate nodes or intermediate clouds by simply their worst case latency, which is a natural thing to do. But we know that by the pay bursts only once phenomenon, by doing that, we might be largely suboptimal. So an alternative, which is exactly what is done in RSVP of INSERV, those mathematical constructions are exactly the ones that are done, is to characterize an intermediate node not by its worst case delay, but by the parameters of its service curve. For example, in INSERV, a rate latency service curve. So if this is what I export, then the end-to-end concatenation can be characterized as a service curve that has the minimum of the rates and the sum of the latencies. And then the delay I will obtain here will have the burst paid only once. So the improvement will be equal to n-1 time the delay due to the burstiness of the initial flow. Now, this burstiness cannot be avoided. It has to do with packet size. It also has to do with maximum number of microflows that we're aggregating. If in a DETNet setting, we are aggregating multiple flows, which we're very likely to do. I know DETNet is not concerned with any change to the control plane. So this is not a change to the control plane. This would be one way to compute an end-to-end bound using an existing control plane of RSVP, for example. Here, then it would simply, if we are able to export some DETNet nodes as a rate latency service curve, then we can simply accumulate the minimum of the rates that are allocated along a path and sum up the latencies. So this is described here for unicast flows in the RSVP setting. It's explaining exactly how this can be done also for multicast flows. It works the same. There's no fundamental difference. Here, if you have a node about which the only thing you know is a bounded latency, you don't know a latency service curve, well, this is a special case of a rate latency service curve with infinite rates. So for such a node, you will be also able to export the right things to do. This has been also studied by a number of people in centralized path computation. If you do a centralized path computation, you can do better things, you can improve it. Some papers have explained how to cast such a problem as a mixed integer and convex programming. I'm giving a reference here on how this could be computed. Thank you. So this was not a timeout. It was just the battery of the microphone being dead. So I think network calculus can help understand some phenomenon like pay bursts only once that may have an impact on the design of an end-to-end service like we're doing in DETNet. It can use to provide perhaps resource models that are more general, and because of being more general, they don't prescribe specific implementation. So, for example, I think an interest, it could be very interesting to add to the DETNet documents how we would use existing schedulers, which is what some networks I know are doing, where we use Linux routers that offer already a large variety of schedulers. So we pick one of them, and then we can do DETNet deterministic networking with such things. So that exists today. There's a requirement to be able to support it. So it would be interesting to see how to fit this in the existing document. It's also interesting, it's been overlooked here in DETNet, but it's very important in other fields like aerospace industry, the ability to prove formally end-to-end delay bounds. It's very difficult in general unless you use abstract constructions like network calculus. You have to try to find out what are all the worst case scenarios, but you're never really sure whether you have in your mind all the worst case scenarios. So it's possible to formally prove this. I give a reference at the end of this slideshow on how the aerospace industry used this to certify some Ethernet AFDX networking, which are very similar to what we're doing here. Voila, I think I've said everything, and thank you for your attention.
Okay, questions? The front mic might be dead. We seem to have, all our batteries seem to be dying at the same moment. There are batteries in the back. Or come on up here if you want to use the mic.
So we had 2 failures at the same time, huh?
3.
But three.
Norm.
It's very interesting, and thanks for bringing it up. Couple notes. I would welcome you to look at work that we presented at SFC working group on applicability of alternate marking method, and there was an update to the idea of measuring residence time in elements, and we refer them as a nodal residence time and subnodal, because residence time is the variable element of propagation that contributes to jitter in a service chain. And actually there is an idea of how to do proactive residence time measurement in a domain so that residence time can be used as a metrics for calculating constrained paths, and the paths constrained with latency and jitter. Will be interesting to see how this work presented that you present can be correlated with their experimental measurements in the WIFE network.
Okay, sure.
Norm Finn. The reason I cut mine short was to make sure we saw this. The characterization of the various queuing methods is the critical part here. I think right now the biggest problem with some of the TSN stuff is that it's not clearly characterized in a way that we can make use of, and I think this is going to improve everything. Thank you.
Okay, thank you. I think I'd like to insist also that for DETNET it would be perhaps not optimal to specify what the schedulers are, right? Because those. Yeah. Okay.
Damien Saussé in Riyadh, do you have any hypothesis on the flow arrival process, or it's like general?
No, there is the hypothesis you're making is that in order to provide end-to-end latency bounds and backlog bounds, that you are able to enforce an arrival constraint. That's the only thing, but you're not assuming it's, I don't know, a stationary process or Poisson or whatever. Of course, there's nothing of that kind.
Okay, thanks.
Yeah, to follow on, this is Lou, to follow on what I think Norm was saying without, because of the problem with the mics, while we don't do control plane here, we do look at how to characterize the nodal behavior as well as characterize the service behavior. And if we can, we have the challenge of developing generic semantics that are not specific to a particular queuing technology. And so if this can help us, that's really useful. So I know you notice you commented, we don't do control plane here. That's okay, because what we really need are the parameters that would be passed around by the control plane anyway, and that we do here. So any insight you have we would, from this work would be very helpful. We do sort of work by text. So if you want to put this, to extract what you think is applicable and put it into a document, that's great. If you want to take pieces, then contribute it onto the working group list and say it probably belongs in this document, then you don't have to have the burden of doing the whole mechanical editing process. But whichever way works for you, we would just like to benefit from the insights you've gained here. I think we have time for another comment.
Be glad to work with you to get some text out of this and get a draft or whatever.
Okay, if I can avoid NROF and all that stuff. Thank you.
Were you coming to the mic? Okay. So with that, we're pretty close to being out of time. We have, there was one good topic that we didn't fully explore, Pascal's impact on architecture. I'd like to suggest that there are people here in the room who are interested in working on that. Get together, if possible, over the next day that we still have left, and see if you can work through that. So I guess I'm really looking at Norm. If you guys might have some good time to sort of work through that and then bring the results to the list. And I'd like to just remind people that we're going to look at an interim sometime early next year. We have to get in sync with the data plane authors to make sure that we have a sufficient update to the document that captures the discussion that we've had today before we have an interim that then would just repeat the discussion. So we want to make sure that it would be worthwhile for people to either travel or participate remotely. I think it would be good to see a show of hands of how many people would be interested. And I'm going to ask first in a virtual interim and then willingness for a physical interim to discuss the data plane open issues and see if we can resolve those. So how many would be interested in a virtual interim working on data plane? Hands high. that seems like some good numbers. What about physical? Is there some willingness? And I know we have to figure out where that would be, and maybe like at a hub location somewhere. Hands, if we had both a reasonable number and a volunteer of a host. So that's appreciated. Thank you. With that, we are exactly on time. Really appreciate all the good discussion and contribution. We might think about having a second session the next time to allow for more discussion. Very much appreciated. See you in London.